Good morning, folks. So we are going a little bit further into the section today. I am going to slow things down though because I realize we are entering AP weeks. So I know several students might have an AP exam that they might be prioritizing, which is fair. So in order to kind of work around those crazy schedules of AP exams, we're going to slow things down and kind of drag this section out a little bit longer than what I would have normally done in the classroom. So before we go any further with sequences and series, I want to introduce a new operator or new operation in math. It's probably something you've seen before, maybe. Um, if you've messed around with your calculator, you might have noticed the exclamation point somewhere in one of the buttons. Usually it's under the probability button or perhaps the number button. Um, but this saying something like 4 isn't really saying it with any kind of enthusiasm or excitement. It's really just saying 4 factorial. And what a factorial is, it's essentially just a product. It's still going to be a number, but if I take the factorial of an integer, keep in mind the n here, we're still working with the same n we saw yesterday. So n is going to be an integer, and it's going to be a positive integer with the exception of 0. So maybe it's a non-negative integer would be better. And what a factorial is, it's the product of n and every positive integer below n. So n times n minus 1 times n minus 2 times n minus 3 all the way down to times 3 times 2 times 1, stop. So for example, 4 factorial is 4 times 3 times 2 times 1, which gives me a total number of 24. So factorials have the ability to increase pretty fast. They get very large numbers very quickly, which shouldn't be surprising because 5 factorial is going to be 5 times as big as 4 factorial. And 6 factorial is 6 times bigger than that. So the only special case we have is this is a special definition. We do have a factorial for 0 because it does pop up in formulas, where 0 factorial by definition is 1. It's kind of like having an exponent of 0 gives me 1. All right, think of it similar to that. Now, working with factorials is usually not going to stay that simple as just saying, oh, 4 times 3 times 2 times 1. So we have a very quick example, which at first looks ridiculous, right? 30 factorial divided by 28 factorial. So if you write this out, it's really saying 30 times 29 times 28 times 27 times, I'm not actually going to write all 30 here on the video. I'm going to try and keep it short, times 3, 2, and 1. That product, most calculators aren't going to give you an exact answer. They're going to give you a scientific notation because this is a ridiculously large number. In fact, the denominator is also going to be a ridiculously large number. It's going to be 28 times 27 times 26 times da, 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 times 3 times 2 times 1. So some students might be tempted to actually go through multiply the denominator, then divide. However, there's actually a pretty smart way to do this. You're going to notice very quickly a lot of these factors cancel. Obviously, these all cancel each other out because they are all, it's one string of products. So they are factors, which means we can cancel them. There's no addition or subtraction. And in fact, all of this middle section is going to cancel all this middle section. These dot, dot, dots, they cover the same numbers. This 26 technically would have been there. This 26 cancels, the 27 cancels, the 28 cancels. In fact, the only thing that doesn't cancel are the two integers that is really the difference between these. So 30 and 29, all of this, as crazy of the numbers that we were seeing here, it's all simply a product of 30 times 29. Now I'm going to type that in my calculator and I'm going to get 870. Very manageable size number for something that was potentially very crazy. Now, let's see another example. So I'm going to actually cover up my work ahead of time. So let's connect this back to sequences because again, a lot of these operations do make their way into sequences and they make their way into probability. Anybody who might take a statistics course or a probability course, factorials pop up quite a bit. So that being said, I want the first 5 terms of this sequence, and the sequence is defined as 20 divided by n plus 1 factorial. So whatever the term I'm looking for, I'm going to plug that in for n and evaluate. So for example, if I want the first term, I'm going to plug in n equals 1, so I get 20 over 2 factorial, which is 20 over 2 times 1, which gives me 10. That's pretty straightforward and simple. And in fact, the next several of these are all very simple, where each one of these is going to be 20 divided by one more factor in the denominator. So A2, I'm really taking 3 factorial, which is 3 times 2 times 1 in the denominator. A3, I'm taking 4 factorial in the denominator, 4 times 3 times 2 times 1. A4 is 5 factorial, A5 is 6 factorial. All right, so each of these denominators, you're noticing a larger and larger one, which means the final term is actually going to be a smaller and smaller term. Some simple reduction of fractions leads us to these 5 terms. So I'm going to cut it off there. Pretty short video today. Allow you to continue navigating a little bit further into the homework problems. And we have at least one more video on this section before we're ready to move on. Probably even spending another day in practice on this. So good luck. Reach out with any questions. Have a good afternoon.